Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I have two bonus problems that are similar to this one which you guys can try to solve. Alright, so I have 5 to the power of x is equal to 7 to the power of x plus 1. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 1, that's going to equal 7 to the power of x times 7 to the power of 1. Now I'm going to go ahead and divide both sides by 7 to the power of x. So then these two cancel out. Now I'll have 5 to the power of x over 7 to the power of x is equal to 7 to the power of 1. Now if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 5 to the power of x over 7 to the power of x, that's going to equal 5 over 7 to the power of x, and this is equal to 7. Now I'm going to go take the log on both sides. So I have log 5 over 7 to the power of x is equal to log 7. Now if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this will equal b times log a. So I can move x here to the front. So this is going to equal x times log 5 over 7, which is equal to log 7. Now I'm going to go ahead and divide both sides by log 5 over 7. So then these two cancel out, and now I have x is equal to log 7 over. Now if I have something in the form log a over b, it's the same thing as log a minus log b. So log 5 over 7, that's going to equal log 5 minus log 7. So now log 7, this is actually equal to 0.8451 over log 5, this is equal to 0.6990. And I have minus log 7 again, which is 0.8451. And this is actually equal to 0.8451 over negative 0.146. And if you divide these two, you get negative 5.7844. So this is our answer. All right, so I have 5 to the power of k is equal to 0. So for our solution, we start with 5 to the power of k is equal to 0. Then I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of k is equal to 0. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would be equal to b times log a. And what is actually so useful about this property is, let's say we have 7 to the power of x is equal to 9, right? Well, if we use this property, before using this property, first off, x, as you see, this is an exponent. And we can't really do much when x is an exponent because it's really hard to solve for x, in this case especially, because this x is going to be a decimal. So by using this property, we first have to take the log on both sides. And then we can use this property by moving x to the front. So we have x times log 7 is equal to log 9. And now, because x is an actual term, it's pretty simple to solve for it. All we have to do is divide by log 7 on both sides. And we get x is equal to log 9 over log 7. So as you can see, this property is really useful for solving for x when it's an exponent. So going back to our normal problem here, we had log 5 to the power of k is equal to log 0. Now we can move this exponent k to the front of the logarithm. So now I have k times log 5 is equal to log 0. Now, we're obviously solving for a k, so I'm going to go ahead and divide both sides by log 5. So then these two will cancel out, and I'll be left with k is equal to log 0 over log 5. Now, log 0, this is actually undefined. And log 5, this is equal to 0.6990. So k is equal to undefined over 0.6990. And if you can't really divide undefined by anything because it's simply undefined. So this means that k is just undefined. It has no value. You can't take the log of 0. And also, you can't take the power of any number and make it 0, because 0 is not possible. You can get 1, because if you took 5 to the power of 0, that would equal 1, but 0 isn't possible. You can't take the power of a number and get 0. Five to the power of x is equal to 50. Now 50, this is the same thing as 5 times 10. So now I have 5 to the power of x is equal to 5 times 10. Now I'm going to go ahead and divide both sides by 5. So then these two cancel out, and I'll have 5 to the power of x over 5 is equal to 10. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So for 5 to the power of x over 5, well 5, this is the same thing as 5 to the power of 1. So 5 to the power of x over 5 to the power of 1, that's going to equal 5 to the power of x minus 1, which is equal to 10. Now I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of x minus 1 is equal to log 10. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And this property is actually really useful because, as you see here in the form log a to the power of b, b is an exponent. And solving for an exponent is actually really hard. For example, if I had 7 to the power of x is equal to 9, x is an exponent, and x is actually a decimal because you can't take 7 to the power of a whole number and make it 9. So this is actually going to be almost impossible to solve by just on your own. But however, when we use this property, we can take the log on both sides. So we have log 7 to the power of x is equal to log 9. And now I can go ahead and move this to the front. So this would equal x times log 7 is equal to log 9. And now I can divide both sides by log 7 because, as you can see, x is an actual term now, and it's pretty simple to solve for. So now we have x is equal to log 9 over log 7. So now going back to our original problem, we had log 5 to the power of x minus 1 is equal to log 10. So now I can go ahead and move this exponent x minus 1 to the front. So now I have x minus 1 times log 5 is equal to log 10. Now I'm going to go ahead and divide both sides by log 5. So then these two cancel out. And I'll be left with x minus 1 is equal to log 10 over log 5. So now I'm going to go ahead and add 1 on both sides. So I have x is equal to log 10 over log 5 plus 1. Now log 10, this is the same thing as 1. So now I have x is equal to 1 over log 5 plus 1. Now log 5, this is equal to 0.6990. So now I have x is equal to 1 over 0.6990 plus 1. Now 1 over 0.6990 is 1.4306 plus 1. This is equal to 2.4306. So that is our answer. Alright, so in this video, I'm going to solve the equation 4 to the power of x minus 2 to the power of x is equal to 240. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So I'm going to first start with my equation, 4 to the power of x minus 2 to the power of x is equal to 240. And from here, I'm going to rewrite 4 as 2 squared. So I get 2 squared to the power of x minus 2 to the power of x is equal to 240. Now, I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So in this case, 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x. So I have this minus 2 to the power of x is equal to 240. And now I can rewrite 2 to the power of 2x as 2 to the power of x to the power of 2. So I get 2 to the power of x to the power of 2 minus 2 to the power of x is equal to 240. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y squared minus y is equal to 240. And now I can subtract 240 on both sides. So these two cancel out and I get y squared minus y minus 240 is equal to 0. So what I have here is a quadratic equation. And to find the solutions of this quadratic equation, I can use the quadratic formula. So if you guys already didn't know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, looking over here, a is 1, b is negative 1, and c is negative 240. So I get y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 240 all over 2a, so 2 times 1. And this simplifies to 1 plus or minus the square root of 1 plus 960 over 2. And this turns into y is equal to 1 plus or minus the square root of 961 over 2. So now the square root of 961 is 31. So I get y equals 1 plus or minus 31 over 2. And now I have two solutions. I have y equals 1 plus 31 over 2, and y equals 1 minus 31 over 2. So my two solutions are 17 and negative 15.